concrete. So in terms of work done, we can also explain it. And I have already explained this in terms of the work done, that it is the amount of work done on concrete uh, in order to consolidate or compact it, and thereby in order to remove the voids. So it's the ease with which we are actually working on the concrete. Now, in workability, I asked this question, and how do we measure workability? That's important. How do we measure workability? Now there are various methods of measuring workability. One of the method is slum test, which is the most common test and the easiest test to perform. The slump cone test. It's also known as the slump cone test. The second one is the compaction test. Then we have the flow table test. Then we have the wavy test. We have remolding test. We have the ball penetration test. We have the 2-point test. Point test. Now there are various tests in order to determine the workability, and there are even more tests for measuring the workability. The simplest one is the slum cone test, which is a cone. It's open at the top, it's open at the bottom. This cone is open at both ends. So what do? We place this slum cone on a plate. There will be a plate underneath it, and we pour the concrete here into this cone in 3 layers. पहले एक layer में, then second layer, and then third layer. So once you have poured the first layer, this one here, of concrete within this cone, what you tamp it with the tamping rod. एक tamping rod होती है, it's tamped with that tamping rod. उससे 25 blows दिए जाते हैं around onto the probably 25 blows दिए जाते हैं, and what you get a consolidated cone in the first layer. Then in the second layer, similarly, it's poured and then tamped again, and the third layer it's again tamped 25 times. Now this is around 300 mm in height. This cone, only the cone, that's 300 mm in height. So 300 mm is divided into 100 mm, 100 mm, and 100 mm each, and it is being tamped. Then the cone is just pulled out. You can check the videos how the test is done. The cone is pulled out abruptly. So what remains is the concrete in this form. But as soon as the cone is pulled out, within no time after the tamping is completed, you do not allow it to set. You do not allow the concrete to set. You just pull out the cone. The concrete may undergo bulging like this. Now, bulging like this means that it's a true slump. This is a true slump. This depicts that this is in a plastic. This is a plastic concrete. If there is a true slump, it's a plastic concrete. True slump is when this sort of bulging of the concrete is happening once you are pulling out. जब आप उस cone को खींच रहे हो बाहर, So the concrete is settling down like this. But then there are more formations, like if something like this is happening, this is shear happening in concrete, and the third one is there is a collapse of the whole material happening. So this is collapse of the material happening. So this is the third one. There is a collapse happening in the third one. So there is a shear failure, and this is a true slump. Now, what does this depict? The shear failure depicts that concrete, the concrete body would have been like this. So it's shearing, it's tearing into two parts. That's shearing. And collapse is total disintegration of the concrete. So there is no plasticity at all within this concrete. And this concrete may have some amount of plasticity in tension, but not in shear. This has plasticity both in shear as well as in tension. So a true slump depicts a plastic concrete. Now there could be concrete which is totally water. It's almost a paste, so it settles down. So it will flow ultimately. Flowing is like this, so it flows. So with increase in, if there is no slump happening at all, that means जैसे ये concrete as a cone था वैसे ही रहा. So there is 0 mm slump happening. 0 mm. मैं आपको ये ऐसे समझाता हूँ. So this was 300 mm in total. तो ये मान लो इसमें 10 mm ये नीचे चला गया. That is the slump value. So we measure ये कितना नीचे चला गया from the original 300 mm. So if there is 0 mm, there is no slump in concrete. So it's a solid mass then. There is not even plasticity. It's totally solid. 0 slump means it's totally solid. Very low slump means it has got 5 to 10 mm of slump value. So there will be the deflection of that cone by 5 to 10 mm. Low would mean 15 to 30 mm deflection. And then medium would be 35 mm deflection. And high value would be 80 mm up till even 255 mm of deflection happening. About 255 mm, it's totally in a flowing state. About 255, it will be not 255, this is 155. Above 155, it normally flows. So you don't call that even as high slump. So this actually tells you the workability. How? 0 slump means you cannot work on 0 slump concrete because you cannot put it into a form work. क्योंकि वो तो settle down ही नहीं होगा. It's not flowing. 0 slump means it's almost solid, so it will not flow. It will not. Very low slump, which is use this. A very low slump. Why do you use the low slump? Why do you use the medium slump? Why do you use the high slump value? Now, for example, you're taking a column. When you are pouring concrete in the column for form work, this has got a large height. Now, concrete has to flow from top till bottom of this, around 3 meters, even up till 5 meters easily. the concrete. So you require a good amount of slump value so that the concrete flows. It should not stick to the reinforcement to the जो steel ऊपर होगा तो उसी के साथ stick होगा तो so there you probably even require 100 mm of slump. So you go for high slump values there column casting. Then